हेलो। हाँ हाँ, लाइव है, एक बार चेक कर ले। अरे उसको बोलना कि हम इसको सीधा स्ट्रीम कर रहे हैं वहाँ पे। पहले एक बार मैं उसकी वो भेज रहा हूँ, लाइव स्ट्रीम की लिंक। सब खोल के चेक करो, चल रहा है नहीं चल रहा। हाँ हो गया वो, मैं एक बार बस खोल के चेक कर ले, खुल रही है कि नहीं खुल रही।
So Atar, so there'll be no interaction in middle, right? It's just gonna be you two in the call. Is that how it's supposed to be?
Yeah, so I'm currently sharing the Google
So
Meet
the
on YouTube,
interaction,
and then we will figure it out. I'm just checking whether or not audio is connecting.
Okay. So what if they had any question or they wanted to stop me in between? So how was?
yeah. So what we're doing is that in the YouTube comment section, they'll be asking the questions, and at the end, maybe like for a good 10 minutes or something, I'll be asking you the questions that we pick out, and so you could answer them. So that will be the setup.
Okay, sure. And which year are you guys in? So that I can just talk based on
So
that as
me and Divij, we both are in final year.
okay.
Me and Divij are in final year, but the audience they'll be like from all four, mostly second years.
Okay, got it.
Hi, so I think the audio is working, and we're just waiting for people to join in, and then we'll start in around 5 minutes.
Okay, sure.
Hi, so I think the audio is working, and we're just waiting for people to join in, and then we'll start in around 5 minutes.
Okay, sure.
Hi, so I think the audio is working, and we're just waiting for people to join in, and then we'll start in around 5 minutes.
Okay, sure.
Hi, so I think the audio is working, and we're just waiting for people to join in, and then we'll start in around 5 minutes.
Okay, sure.
Hi, so I think the audio is working, and we're just waiting for people to join in, and then we'll start in around 5 minutes. check, mic check. Mic test, mic test. हेडफोन नहीं लगा देना, आवाज़ कैसे आएगी? Yeah, everything is fine.
rely on blockchain, and and your payment is done, and you'll be able to do this in a much trustless way. So this is a very simple example on how a trust is minimized, and it's more about being very transparent, and how blockchain facilitates in this particular example. So yeah. So now coming up to this, about how did blockchain even come, right? So it came from a creator called Satoshi Nakamoto. So he was the creator of Bitcoin. So Bitcoin was more about peer-to-peer electronic cash system, through which you had something called UTXO. For example, if you do a transaction on the UTXO, it's just removal of balances and addition of balances, and every transaction is again on the blockchain itself. So this was the first time where the whole talk about blockchain and everything established, and it is by a pseudo. And Satoshi Nakamoto is not just an actual name; it's just a pseudonym. No one knows the creator and all this kind of stuff. And yeah, I mean, if you had seen a lot of stuff on net, you might have also seen about the talk about where a guy paid about 10,000 bitcoins just to buy a pizza for his daughter, which now values more than about 500 million, or a lot. It values a lot. So this is where the whole blockchain thing comes up from. So yeah. So now coming on to how it works. Now paper blockchain, as in like, you have a particular village, and your village has a residence, and there's Alex. Alex is the one who facilitates all these, I would say, ledger and transactions, who keeps a record of all these transactions. In this particular case, now if we move on to this particular case, right? Now in this particular paper blockchain, the public database is in a chronological order. For example, if I did a particular transaction in this particular village, so my name starts from A. So people who have their transactions, like if I did a transaction, then my transaction would come first, and you'd be able to see this in their public database. But what if Alex was absent during that day, or he went into a vacation, or he just got sick, or what if he got robbed, or what if he just moved out of the company and all those kind of stuff. So what if all these happens? So these are the cases that happens when everyone is dependent on Alex. So Alex is basically the go-to guy for all the cases of what the residents or the village wants, right? But what if Alex just disappears all of a sudden in a day? There's no one, so the whole process is just gone down. So there's no one else to help you guys out in the help these villagers out in this particular case. And it's very centralized, centralized as in a single authority having a lot of power in this particular case. So that's where we talk about centralized and distributed networks. So in our case, where we were talking about Alex, that was a case of centralized. Distributed networks is more about, for example, I do a transaction, from A to B. Everyone in the network will also be able to see that particular transaction, and will also be able to validate, and will also have a copy of that particular transaction. So this is what the distributed and centralized, centralized networks, or centralized scenarios depict. So just in simple words. So yeah. Now they also have peer-to-peer networks, and then they also rely on consensus algorithms. So consensus algorithms means, for example, so there are a lot of different consensus algorithms. For example, there's something called proof of stake, proof of work, and proof of stake. So the meaning of these are, for example, if you want to validate or mine a particular block, right? You will have to solve a particular mathematical equation in order to be able to mine your block, and add that into your block, add that to the blockchain. So once you do that, you will be able to receive a particular amount of incentive for doing this. So the consensus algorithm is always important in any blockchain, as this is what keeps the network strong. The more the number of stakers or the more the number of miners in a particular network, uh, the much stronger the network is. Yeah. So now coming on to how, so we just saw a particular case of the paper, right? Now coming on to the digital one. So for example, once you do a particular transaction, right, your particular transaction is then given is then attested with a particular data, which is the date and the time. So the date and the time is attested to that particular transaction. So you'll be able to see when this transaction was done and when this, at which particular date or time was. Right now the block production rate is much uh, higher, I believe. This is a pretty outdated data. So in place of this a paper, the transaction is all the transactions that one does or the whole network does is added onto a particular block. So that's what this denotes. And instead of having Alex to attestate that, this is a proper transaction, we have a particular consensus algorithm. So the consensus algorithm that I was talking about, it could be proof of stake or proof of mine. So that's what this particular thing depicts. And instead of having reliability on what Alex says, we rely more on the cryptography. So cryptography can never go wrong, so we rely more on the cryptography itself. And here the way that you saw in that particular example, it was arranged in a chronological order, but here it's based on how these blocks are intertied with each other. So for example, so each block has a lot of data. For example, one of the data, the main data is called block hash. So you'll be able to identify a particular block using its block hash. So the block hash can change. So I'll just show you an example quickly. But basically, every block has its block hash, and every block is interconnected. Interconnected as in, if there was a block A, B, C, if A is considered as a Genesis block as in the first block in that particular blockchain. So the next blockchain, sorry, I'm sorry. So the next block would have this current block's hash as well as the previous block's hash. So the block hash is calculated based on data like the data present in the block, the time that it was created, and all those kind of stuff. So based on those criterias, and the using the hash function, the hash of that particular block always changes. For example, if you just, I can show you a quick example. Let me just pull this up. Where is that? Okay. uh, Here it is. Are you guys able to see the screen? I'm on a new tab. Are you able to see that? Atharv or
Yes, we
Jude,
are able to see your screen.
this is what I was talking about. So block one is always it's considered as a genesis block since it's the first block in a particular network. So the block has something called nonce. So nonce is that uh, and no block can have the same nonce at the same time. Akash, so what previously happened was, so let me watch. So we have block number, we have none the hash. Since this is the first block, the previous hash is just 0. Hash of this is basically the block number, the hash of block plus the hash of nuns plus the data, and that's what the hash, this hash means. So if you see in the second block, so we have the second block here, we have a different nuns, and we have no data. What this has is the previous hash of this particular block, right? So for example, now if I say, my name is Akash, what happens is that this particular hash has changed. At the same time, the previous block hash has also changed. So this basically is invalid, right? So for example, no one can enter a particular block and say that, I want to mutate this particular I want to okay, so I want to mutate, so I want to change this particular word data mutate into immutate, right? You cannot do that because each and everything is dependent on this particular, like each are interdependent. So you do any change, the hash of it changes, and the previous hash also changes. So it just turns out into an invalid block. So that's what I was trying to say. For example, now if I try mining it, nothing goes through, right? Now, for example, if I just enter some word here, this mines, but this says, okay, wait. Okay, yeah. So the it's so again, previous hash. Uh, so basically, I've changed the data. I've clicked mine because now the hash of this is equal to the hash of this. But then this is not a proper block, since the hash of this is not the hash of the previous block as well. And if you go forward as well, you would be able to see that the previous hash uh, is different from the other hash that we were talking about. So this is a pretty good example of to know how these blocks are interconnected and how these work. And yeah, let me just go through this again. Okay, so yeah, this is what I was trying to talk about. So just a summary about what we spoke. So blockchain is so blockchain is but basically a public ledger through which anyone can just see the data as they feel, and nothing is private over here. It's all available publicly, and it's not centralized. While it's always blockchains always focus on decentralized networks. Um uh, so and what did I miss out? So yeah, yeah, these were the two things, two main things talking about blockchain itself in the point of public ledger. So they are a public ledger, they are distributed, and they are decentralized. So they always have a consensus mechanism, and they are immutable. So once something is added onto a blockchain, it cannot be mutated. So these are the main stuffs with respect to what blockchain is, and yeah. Now, coming on to the use cases, I think I forgot to add this particular slide. But there are a lot of use cases with respect to blockchain. So the top use cases are use cases are DeFi. DeFi meaning decentralized finance, where you just use your wallet. You're not dependent on your banks. You just have your own wallet, and you're able to you're able to buy or sell assets using dex as in decentralized exchanges. And there are a lot of products with respect to DeFi itself, and there are few other topics that have been trending around, which you would always be able to see through this. uh, but yeah, talking about the use cases, there's something called RWA as in real world assets. Instead of having a lot of paperwork uh, to be done while purchasing a particular asset can be land or apartment or anything with respect to that, right? So real world assets enable you to do all those while just holding a particular NFT, and being able to show that you have the ownership over a particular asset. So there are a lot of category, like I mean, there are a lot of use cases with respect to blockchain. Again, medical I mean DeFi, the one that I talked about, then RWA. uh, there's a lot, and I'm just not able to recollect them. But yeah, so uh, okay, so I'd highly recommend you guys to just go through this particular website. It gives you it gives you guys a good overview with respect to uh, what are the different products with respect to blockchain and DeFi in specific, right? And it also gives you like the top trending protocols, and how you guys can leverage that, and it also gives you like a good idea with respect to how you guys can develop a particular project as well. So yeah, so those are talking about use cases. There's a lot, but right now, just pitching on my mind, I'm thinking of DeFi, RWA, and then medical, and then what else. Oh, guys, I'll just search it and I'll tell you. But yeah, these are the three things that are popping up right on my mind. But yeah, these are these are the top things that I could talk about. But yeah, now coming on to the opportunities within the blockchain ecosystem, right? So like the average pays in the Web3 space within Asia is about 58K, and it just keeps getting updated. This is I believe this is like an outdated version. I think this was somewhere around 2022. But I believe these salaries have been increased now by a lot. And uh, and also talking about opportunities, right? Like, I don't think a lot of opportunities, you would get a lot of opportunities, these opportunities within your colleges. So these opportunities can be only availed when you guys just move, search outside of college and not within the college. And Now, talking about opportunities again, I would also like to talk about only dust here. So yeah, so basically, Only Dust is like a platform where you get incentivized for your open source contributions. So this is how I also started. Not started. I got into midway, and this was pretty helpful in terms of everything with respect to learning, with respect to getting incentives, and it gave you like a it gave me like an opportunity to not be dependent on a lot of internships, but you can work on yourself and also for other projects that are available in this particular platform. And yeah, and you just once you just pick up a particular issue, and you complete that issue and raise PR. Once everything is good to go, you get incentivized. But yeah, now talking about what Only Dust is, so it's an onboarding, it's a platform for onboarding developers to blockchain ecosystems through open source contributions. I can show you guys like a hands-on thing. I don't want to go very deep into this. Uh, but yeah, the idea is that you'll be able to get connected with like-minded builders within the space, and it also allows you to grow within the ecosystem. And you also have the chance to launch your own open source projects, and also be able to find a job and build a company as well. And right now, the only Dust platform works with around 5 blockchain ecosystem, and has about 270 plus projects. And these are the number of registered contributors, and these are the devs on being onboarded. And these are the this is the amount that is being distributed as incentive monthly wise. And yeah, I let me just not go in too much into slides. I think I'll just show you guys hands on. Okay. So basically, this is the website. This is the platform. It's called app.onlydust.com. So what you can essentially do is, so basically, you just create your account and all those sort of stuff. And what you can do is, you just scroll through. You go to the project section. You can just scroll down to see a lot of projects with respect to this any ecosystem. But here, these are the ecosystem that is supported. But I'll highly suggest you guys check out Starknet. So you guys, you can just search either through ecosystem or languages, whichever language you guys are aware of or very proficient in. And you can just based on that, you can filter out stuff, and you can start contributing. So for example, what I would do is, if I was new, and uh, if I was gonna be in your place, right after looking at this particular website, I would just scroll through a lot of projects. I'd just go through the projects, and I'll just pick up which excites me with respect to how that particular project is, and what will I be able to learn with respect to that, and all those kind of stuff. So these are the ways that I look into while contributing to a particular project. So once you just click onto a particular project, right? For example, let me just go to uh, here's the project. Okay, let me just go to Dojo. So for example, I just go into this particular project. So now I want to start contributing to this particular project, right? So you'll be able to see something called good first issues. So good first issues are something that anyone can pick up. It's just very simple issues. Uh, so all you have to do is just apply, and once you apply, someone will reach out to you through Telegram, and they'll add you in a particular group, in a Telegram group, where all the contributors from this particular project will be present over there. So that's one way of you being able to network with everyone and be able to learn from your peers. But at the same time, now once you've applied, right? So let me just check. Uh, okay, this is about sending an application and all, but let me just go through another project. Okay, let me just go to art piece. So for example, so I don't see any good first issues, but what you can do is just scroll down. You'll be able to see something called repositories. Click on repositories. So once that is done, you can go on to issues. And now what happens is that these are the three issues that are available. Now for example, you say that you see that this is something relevant to you and that you can finish it up or wrap it up. So every issue will have its like it will have the instructions on how what's to be done and how can it be done. And all you have to do is basically, okay, there's been a lot of comments here. So all you have to do is basically say that you're interested in taking this particular issue. So once you say that you're interested in taking this particular issue, so the one who's responsible for this repository would basically just come under your comment and say that they'll just assign this particular issue. Let me show a better example. Get a see. Okay, okay, wait. Okay. Let me just open this. So the reason that we were not able to see a lot of issues that this is about to be completed. The project is about to be completed, and there were about 92 issues, and 92 issues were closed now. So let me just open this up quickly. So the issue and the instruction is given, and the references is given. So basically, you can just come and say that you'd like to get assigned, and once, sorry, what happened? Okay. So once you say that you want to get assigned to this particular issue, the one who's responsible for this particular repository will assign this issue to you. So how is this connected with only Rust, right? So once he assigns you a particular issue, you'll be able to see that into your dashboard. So you'll be able to see that this particular issue is in progress, and once you complete that issue and raise a PR, and the PR is merged, you'll be able to see that here as well. So once your PR is merged, then what happens is that he will be sending out he'll be sending you out incentives but for your particular contribution. So there's a lot of projects available here through which a lot of people have been contributing to this and have been getting incentivized like a lot. And uh, and this and this doesn't actually require you to be very concentrated on a particular internship and all those kind of stuff, but you can focus on a particular project. And from that, once you have like a good contributions over your particular portfolio, like any company or any project within the ecosystem can just come onto your particular portfolio, check your portfolio, and they'll be able to like hire you within the ecosystem. So yeah, so this is where you'll be able to see like your amount rewarded, pending amount, rewards received, and all those sort of stuff. So for example, that you've raised a PR. Once you've raised a PR, you'll get your incentive. You'll be able to see your incentive here, and you can either cash it out directly through your bank account, or you can just get it onto one of your Starknet wallets or your MetaMask wallet as well. So yeah, this is pretty much it. And I think this would come like it would be a huge use for all the people within colleges. I think this is a pretty cool way to like learn, contribute, and get incentivized. Not only that, you'll also be added onto a lot of groups. For example, we saw the project called ZK Ramp, so you'll be able to see all these people within the group whom you can get connected, and ask any questions. It can be dumb, it can be anything, it doesn't matter. You can ask questions here and they'll be able to answer all your questions with respect to this particular project. So this is a way through which you can also level up your particular skill. So yeah, the this is pretty much it. uh yeah, I think it showed a timer of 15 minutes, I believe. The call ends in 30 minutes. I think the call is going to end in 30 minutes, 13 minutes. Maybe we can just open up few questions. If we have time, I can maybe talk more about Starknet. Yeah. Hello, guys, are you
Yeah,
there?
I think they'll start commenting the questions. We'll just wait
Yeah,
for the questions.
yeah, yeah.
Someone has
And
commented that how do zero knowledge proofs work in blockchain technology?
okay, so yeah, for talking about that, I'll have to go through the basics of Starknet. I can do that, but I think it'll take a bit of time because it shows your call ends in 12 minutes. So basically, for example, over here, right? Okay, so I don't want to rush into things. Let me just give a very slight glimpse on how zero knowledge proofs work on blockchain. For example, now when so there's a particular dilemma. So there's a particular problem called blockchain dilemma. Let me show you guys that. Where is that? Just a second. Okay, so the blockchain dilemma is that, for example, if a particular blockchain focuses on scalability and decentralization, then they might leave out on security. At the same time, if a particular blockchain focuses on security and decentralization, Ethereum focuses on, then they lack on scalability. So the reason of L2s, right? A lot of layer twos uh, being evolved in the space is because of this particular problem. So Ethereum focuses on decentralization and security, while it loses the capability of being having that characteristic of scalability, and that's where all these L2s come in. And now talking about how ZK proofs work, right? For example, now that this particular block producer says that this is the state, right? So for example, this block producer says that the new state is 42. Now what the validators will do typically will be that they will have to re-execute all the transactions within this block and then verify, and only after that is done, only then the block will be like valid. But once when you have ZK proof, right? In our case, Starknet uses something called Starks, which is very different from Snarks. Snarks needs a trusted setup in order to verify your particular proofs. But at the same time, on Starks do not need any trusted entity in order to verify your proofs. So now coming on to how these ZK proofs work over here is that once a particular so for over here in this particular block, the block, they say that the state is 42, and you don't just get the block and the new state, but also you get a proof generated along with it. So what happens is that the validators, right? They just need to verify this particular proof. They do not need to like re-execute all the transactions over and over. This is that particular effort, and hence this is where the whole CK proof comes into play. So yeah, and if talking about the execution and verification, for example, if the sequencer as in like so all the L2s, right? All the L2s have something called sequencer. So sequencer is like the entity that produces blocks on L2s, right? And all L2s are not decentralized, all L2s are centralized, and all the L2s are focusing on decentralizing their sequencer. So yeah, so basically now talking about sequencer. So sequencer is responsible for producing blocks. So now a particular block has these many transactions, right? And now the validation on L1 as in on Ethereum. So the sequencer is on Starknet, and this validator is on Ethereum. So now a sequencer produces a block. Now, for example, if that on L1 the validator wants to verify verify this particular transaction, the what do you call that? The rate at which it is compared to the sequencer, it's just log square n. So that's very minimal, which you can see in this particular graph as well. Even if the transaction computation done by the sequencer on L2 is a lot, on L1 where the scalability issue lies, typically the the verification is much lower. So that's what this particular graph depicts, and this answers why zk proofs are used on blockchain itself. So yeah. Is there any questions?
Right. So
And
we have one more question from an audience member. They are asking about how are cryptocurrencies being used in like real world applications like today.
so in real world applications, so cryptocurrency, so that's what I said, right? Talking about DeFi, so DeFi is like the place where all your cryptocurrencies are put into use. So you'll be able to do a lot of things. For example, liquid staking, lending your tokens. You'll be able to uh, trade your tokens from a particular, from Ethereum to Stark, or Stark to Ethereum, or any other token. You'll be able to restake. You'll be able to. So basically, there's a lot of capabilities which cryptocurrency allows. And talking about it in a very broader term, talking about it in a very broader term, and not going to into this like whole Web3 space and stuff. So cryptocurrency helps in breaking that barrier of uh, you having to need to have that verification with or verification or regulations in a particular country. Instead, you can just use your particular cryptocurrency and be able to transact uh, an amount to anyone present in any part of the world. So that's what it allows. But with that's not the only use case. There's a lot more use cases. As I said, you are able to so your cryptocurrency is yours, and no one else can take that up from you. So there's no intermediary here, in order to come and say that, no, this is not going to be valid one day, and all those kind of stuff. So yeah. And
Right. So we'll move
there's a
on to
lot
the
of
next question.
ways to. Yeah, for sure.
Yeah. So sorry to interrupt, but one of the questions they have asked is, what are the key takeaways from Starkware's innovations, and how does Starkware enhance blockchain privacy and security?
Okay, so basically, Starkware has two products. So Starkware has something called Starkware has its public blockchain called Starknet, and Starkware also allows in creating app specific chains using StarkX. And the other one is that the CEO of the company, Eli Benson, is the inventor of Starks. So yeah, so he's the inventor of Starks. So Starks is what's being used over Starknet, and Starknet. So why Starknet at the first case, right? So Starknet is responsible for scaling Ethereum. So due to the issues on Ethereum, right, which is the scalability issue. For example, if there's about like a DApp that has about like 100K users or something like that, and everyone do a transaction at the same time, you have your gas fee for that particular time just peaks out. So talking about gas fee is nothing but like a transaction fee that you pay in a particular blockchain. So there's a lot of congestion, right? So that's where all these L2 come, and that's where Starknet comes in. Is the only blockchain that uses Stark proving, which, for example, each transactions that you do gets a proof. There's a proof generated, and in order to ensure that this particular transaction is valid, you do not need the entity to know the data itself, and you need not know have a trusted entity. As I said, that's the huge differentiation of Starks and Snarks. So anyone can just verify this particular transaction, and yeah. And whereas right now uh, the top blockchain that has the lowest gas fee is, by the way, Starknet itself, which is about $0.003, which is about like 3 cents or something. Whereas compared to while comparing it to the L1, which is about like $10 or $15, and it can go up anywhere up to $300 as well. So this is like the huge factor.
Right. So I think this answers all the questions that they have asked. And since we are running short on time, I think this was the last question. Sorry if you have any other questions, but I'm pretty sure that we got a broader knowledge on almost every topic. And I would like to again thank Mr. Akash from Starknet to join us, who took his precious time to join us and give us knowledge about blockchain, as it is a very interesting topic and never ending almost. because even today, like, even though I about blockchain, being from VIT blockchain community, it still brushed up our knowledge on the basics, and it was interesting to know how Starknet works, etc. So again, thank you, Mr. Akash, for joining us, and I hope all of you had a wonderful session and knowledgeable session. So thank you everyone for joining, and thank.
Just a side note again, feel free to scan this QR code. This is like the go-to place for you guys with respect to any resources, or you guys can contact me as well if you have any questions even after